Hey, Akansha. Hey, Robert. Hey, Siddhant. Hey, everyone. Welcome. Tim. All right, I'm going to bring Tim up as well. Let's go. Let's go. Akansha, can you confirm if my audio is coming across well?
I didn't get you. Could you speak?
Oh, can you? I just wanted you to say if my audio is okay.
Yeah, it's all good.
Awesome.
Yep.
Awesome. Good. Welcome, Robert. Good morning.
Good morning. Thank you.
How's it
Welcome, Tim.
how's it going, y'all? I'm a mid round in Call of Duty, so I'll be like a little in and out.
Do you are you doing like Warzone?
No, I don't do Warzone. I don't like the battle royale styles.
Oh yeah.
They're just never really appealed to me. But
hmm
I do like the standard kind of team deathmatch, the various objective based ones. Those I like.
Yeah, interesting. All right. I probably should pick that up. Anyways, yeah, gotcha. Okay. Well, we'll give it a couple more minutes to let some folks come on board.
I was gonna say, Maria, you're just too sweet a spirit to really be a Call of Duty guy. I feel like.
Yeah, it's funny. I do play COD occasionally, right? And I'll hop in there and I'll hesitate to like pull that trigger or anything like that, and my heart will start beating like, oh my gosh, and I'm like running away. Yeah, you're right, man.
Yeah,
You're absolutely right.
yeah. If anyone I know is too nice to play Call of Duty, it's you.
I do play though, like on occasion when I've got some time.
We can maybe we can co-op on some Minecraft or something like that. That might be nice. We'll play on peaceful so there's no creepers.
uh, Killing me. um, so yeah, I just got back from ATO in Raleigh, and it was a fantastic event. Actually, Robert was with me over there, and it felt like a smaller KubeCon, and in a good way, in a really good way. So it gave me the opportunity to interact with folks and just see what they were up to and what they're tinkering with these days.
Hmm.
Just sitting on some talks, and holy shit, I was able to catch Ciora's keynote. I caught Fatima's keynote, Emily's keynote as well. James Quick, oh my gosh, fantastic. Um, and you know what? None of it was about like tech. It was really about like the people behind it, right? Working with community, being a part of it, immersing yourself, you know, being inclusive and whatnot. And I love that. I hate keynotes that get into like deep tech or feel like very sponsors specific or something.
I mean, the very nature of open source is not technical; it's collaborative, right? That's the whole point of open source.
Exactly. And that's why we are here. We are here to collaborate and talk about platform engineering. I mean, I've actually never had the opportunity to just jump on my own space and talk about it because I've just been so focused on my little bubble of application networking that it's a part of this whole platform engineering movement and specification that exists. But let me stop and maybe pass it to Akansha to maybe share some thoughts, maybe set the stage and some context.
Yeah, I will set up the stage. So, yeah, hey everyone. Hi, Robert and Tim. Thanks for joining. So, in this Twitter space, we are going to talk about a relatively new hot topic in DevOps and cloud space, which is platform engineering. And there is a lot of discussion going on where some people are asking whether platform engineering replaces DevOps. Many people say it goes hand in hand and is rather an addition to DevOps, but in reality, it's a bit more complicated than that. So, platform engineering actually changes a lot of established rules we knew about DevOps, SRE, and cloud engineering. It changes the game and introduces some new rules. We are aware that DevOps engineers tend to be obsessed with their favorite tools and platforms that could be Docker, Kubernetes, Terraform, or any other among the set of those labeled as DevOps tooling. However, that is often missing the point of what we are trying to accomplish. The goal should be to enable everyone to be in full control of their applications, including dependent services and infrastructure. DevOps is about having self-sufficient teams, and the only way to accomplish that is by providing services everyone can consume. Instead of waiting for requests to create a cluster, perform security scanning, deploy an application, and so on, ops and other specialized teams should be enabling others to do those operations as and when required. So that enablement is best accomplished by creating an internal developer platform or IDP. So today, let's clearly define what platform engineering exactly is. More interestingly, why was there even a need for this new role, or and how it evolved, and of course how it compares to DevOps, and does it really replace any of these roles? So let's deep dive into this, and yeah, over to you, Marino.
Yeah, let me actually pass it to Robert or Tim to maybe add on to that definition a little bit. I'm learning. I'm in learning mode today, and I'll share some of my own thoughts a little bit later on. But whichever of the two of you want to take it, go
Sure, I'll
ahead.
take it real quick. So I want to at least, I feel like we need to kind of clarify where we are when we talk about DevOps and the relationship between platform engineering and DevOps. DevOps is not tooling. DevOps isn't even about self-sufficient teams. DevOps is about collaborative and iterative development, right? First and foremost, without any tools, without any tooling, you can still have DevOps as long as you have a conference room and a whiteboard, right? Um, Everything else is just implementation details for DevOps, right? But the DevOps itself is a culture. Platform engineering is tool building. You talk about a quote unquote DevOps engineer, whether they build these other tools for like CI/CD pipeline. That's still just tool building, but that's not DevOps. It's not. It's like saying carpentry is a hammer. Well, no, it's not. Like you can use a hammer in carpentry, but it is far more than that. The same holds true for DevOps. So I feel like when we try to distinguish between platform engineering and DevOps, we kind of lose the importance of what DevOps is by trying to say it's a set of tools, and it's far more than that. And so, to that end, I do feel like platform engineering is a way of accomplishing DevOps in certain orgs.
I love that definition, Robert. Go ahead.
I'm not sure if there's anything I can add to that, but I will reiterate that I do appreciate the fact that we're calling out that DevOps is not necessarily an individual, that it is cultural.
Yeah, I believe Google was the first to come out and define it as the SREs that would implement DevOps pillars and principles to effectively just make sure that systems run and are always upkept and updated and patched and whatnot. Now, that practice of platform engineering, like I want to establish some pillars because I feel like if we start looking at pillars or looking at this from a pillars standpoint, it becomes a lot clearer as to where platform engineering, the tooling behind it, the practices behind it start to fall into place. So from my point of view, there are a few pillars that I look at: security, being able to build pipelines, being able to provision and automate that provisioning, so you're not sitting there with manual touch points and having to configure things by hand. Building out your connectivity platform, you need a fabric to be able to allow a variety of styles of workloads that create your service to communicate with each other and find each other. And so there's also this element of orchestration, right? You've got these different kinds of workloads that you have to orchestrate. You have to sit there and decide like how a workload should run, where it should run, when it should run, why it should run the way it does. And then you need to be able to see everything with tools, with observability tools. And so you think about those different pillars that I've just laid out, and and then you start to think, okay, we've got those pillars in place. What about the actual practices behind that? It actually is an interoperability game in my view, because you're sitting there having to take business requirements and jam them on top of technology, because that's all you really see, right? So you're presented with all this technology, But where platform engineering should be coming in is to take those business ideas and translate that into technical challenges, technical areas that then further align to different solutions that can work together. But it doesn't end there, right? Because in order to match those business requirements, someone's building not only a platform, but an application that lives on that platform. And so you might have the situation where they're operating at different speeds. And so you have to think about how to match those speeds. And this is where the whole notion and concept of DevOps comes in. So you're now matching the speed of operations and building out a platform to the delivery of an application and how it's built. Um, but then comes the particular consideration around, who owns everything. So I'll stop there because I've just mentioned a bunch of different things. Does anyone want to take it from there and
I'd
bridge
like
that
to say
gap?
this. This is Robert. I'm sorry, but I think could we ask the question? What I get a lot is there a role as a platform engineer, or is it a group of people who make up platform engineering? And I'm curious to have Tim, Nashanka's, and Marina's take on that because I get that question quite frequently.
So I'll start with that, and I would say that I can see a role of a platform engineer, only because it's not necessarily ops, like it's ops adjacent. It's not necessarily like SRE, it's SRE adjacent. Because you're building essentially a SaaS for developers, right? Um, and in so doing, if that is your role and responsibility of building and maintaining and iterating on that SaaS, right? Are you a software developer? Not really. Are you an SRE? Kind of maybe. Are you an ops? Kind of maybe, right? So I can see where these overlap in areas of responsibility, maybe in a person, but absolutely in a team. Like platform engineering is a team, it's an org, right? Um, as to what you want to title the members of that team, in the end, I don't think it really matters much as long as you pay them.
I think that's critically important, right? Like, there. It's not to say that titles don't matter, but clearing up what a particular role on a team does is going to be very telling of whether or not it aligns to platform engineering altogether. I mean, when I go out and visit various conferences, um, and I interact with some folks out there, I don't always see the title platform engineer. I might see site reliability engineer, I might see DevOps engineer. And when I speak with them and understand a little bit about their org structure, it's exactly what Tim said. You got an organization that is basically platform operations or platform engineering, something around that to that effect, and it is effectively doing the thing or offering up the thing that platform engineering truly is. So when you think about job roles and whatnot, I think it's most important to understand the functions that you want to be doing, or the kinds of activities that you want to be taking on, and then the projects that you want to focus in on. And then what that truly means is you're thinking about ways you can take an application or a platform and scale it as an example of something you'd want to do. Or you'd find ways to automate several processes, which normally an SRE would do, right? They would use some of that programming knowledge or development knowledge and develop some sort of application or automation to wrap around a process, a repeatable process that they would do. So if that's something that aligns to you, then you're pretty much barking up the tree of platform engineering. But then there's that element of collaboration, right? Not every platform engineer or SRE is going to focus in on everything that's in that entire base, right? There might be a shared responsibility model within that team, and it might be ratioed in that several engineers focus in on maybe the data portion of it, while others focus on the overall infrastructure, while others might focus on the outward facing components of the application or there might be other pieces, right? And you have to think about the fact that amongst those different sub teams within the platform engineering org, they're going to have to collaborate and communicate amongst each other to ensure an upkeep of a system or a little service. But it was interesting. I was chatting with Vic Vijay Kumar when I was at ATO, and he's an engineer, principal engineer for Twilio, and he was mentioning that he's responsible for, I think, 10 to 12 services in Twilio. And it was interesting just to hear like the process and the mindset of it. So he operates like a platform engineering team effectively. They own the services, they ensure that these services are online, they have an on-call model to ensure that if a service goes offline, there's a process to triage it or triage the issue, as well as work to resolution, and then even a root cause analysis following that. But when you think about that, right, that's something an SRE has always done. So let me stop there. I've spoken quite a bit.
I do think we do need to add like one aspect of it too, is that when you're building a platform engineers, when you're building a platform, it's not just for the developers, right? It is ultimately for the end user, right? For the customer. So you have to think of the end goal, right? I'm going to build a platform so developers can build something that is going to be consumed by the end customer, right? And so you cannot just build for the developer because you're only going to be halfway, right? I had to build something that can be consumed by the public as well, right? So your pillars of resilience and security and performance, sustainability or cost optimization or whatever, cannot just be so that developers can build their applications. It has to be so those applications can be consumed by your end user. Oh, and the reason I think that's important, real quick, one last thing, is just because your business goals are going to dictate a lot of what this platform looks like, and a lot of how those responsibilities are divvied up, right? If I'm building a database SaaS, right, or that's my primary business, that platform that I build is going to look a lot different if I'm building an API.
I think that's an excellent point you bring up, Tim, because let's say that one database as a service app, SaaS app, right? It is, while specifically built for a client to consume, someone on the external side to consume, it still has to offer up some sort of API where multiple individuals in the organization and external to it can work with it, can extract data from it, can modify it as they need to, can add to it, to iterate to it. So exactly, your point is you take a platform, you platform engineer it, and you're extending that API functionality to pretty much anyone that's allowed to access it, but specifically in the way that they need to. I mean, not everyone will have access to addressing the underlying infrastructure, while you wouldn't want to give your end clients that access, obviously, but it'd be controlled API access.
Yeah.
Go for it, Robert.
I think one thing to remember, that not all platform engineering teams are going to look alike, and that they're all going to be unique based on that, what Tim said. If you're building a DB SaaS, don't try to use that model and shove it into, I'm building the next Heroku over on this side of the house. They're not going to look the same, and you have to treat them each individually based on the skill sets of the people there and the needs of that particular product.
Exactly. No, that's perfect. Akansha, do you want to add any thoughts as well?
I am really enjoying this conversation, but I did have a follow-up question to what Tim had said earlier. So if Tim would like to answer that,
please.
I can ask the question.
Love to.
Yes. Okay, so like you gave a really good explanation about platform engineering versus DevOps, but I want to talk about a common fear that folks have. Let's say that we build this abstraction or a product that sits in between the developer for creating a Docker image or anything.
Mm-hmm.
It's a self-service model. They click on something, the workflow initiates, they get the Docker image, build a container, and deploy, all done. then do you think this will diminish the responsibility of a DevOps engineer at an enterprise scale? Because, lots of companies keep hiring DevOps engineers because they want them to build these pipelines. So if we are productizing this whole platform of CI/CD or DevOps, then what will be the role of a DevOps engineer? And like you mentioned, that platform engineering in no way kills DevOps, since DevOps is more about collaboration. But maybe we could paint a more clear picture about how these two roles work
All
together.
right, so this may be a controversial hot take for a Wednesday morning, but I don't believe the role of DevOps engineer should exist. Because like, what does a DevOps engineer build, right? Pipelines. Okay, so once it's built, then what? Once it's built, are you maintaining it? Because that's operations, right? Once it's built, are you if you're doing the maintaining and monitoring, whatever, that's ops. So I don't see again as a culture, right? You can't have an engineer for a culture, right? If you're talking about tooling, right? It's the same people that maintain any tooling. It's operations, right? So if we're talking about what are these people who are building the pipelines doing, right? If you're building the pipelines before, I don't see why that would preclude you from being now a platform engineer, right? If that's what you're essentially, you're taking those pipelines, you're taking those methods of delivering, the applications to production, right? And you're productizing it. I don't see why I don't see if that's your role. I don't see why you aren't already a platform engineer, if that makes sense.
That is quite hot take, but yeah, okay, I get that. So let's say a particular organization is already using traditional DevOps practices and it's been serving them quite well. However, they might be realizing that moving to a platform engineering approach might be more beneficial for them.
Mm-hmm.
So what are some things that they would need to consider before migrating to platforms? Organization of different scales might have different considerations. For example, a small scale startup might just have a GitOps pipeline in place and they use a couple of simple Helm charts for their deployments. However, a large scale organization might have some very complex set of practices, such as infrastructure as code with Terraform or Pulumi, then maybe some other automation with Ansible or Puppet on top of a GitOps pipeline or similar.
Mm-hmm. Well, I think the first question they want to ask, especially as a small company, is why, right? If you are small and you're kind of running small and you're not building up for a larger, we're expecting a lot of companies, or we just hired a big kind of contractor or whatever. Why do you need to transition to platform engineering? Right? It's the first question I'm going to ask you. Right? I'm very much a big fan of it. If it ain't broke, don't fix it. If there's no real necessity to do that change, and what you have is working fine, then don't do it, right? But if you are an organization that's growing, you have to make a platform change for some kind of reason. Then you're going to look at, what are my requirements? What am I building? Who am I building it for? Like we talked about before, like what is your primary business? Is it an API? Is it that we're building? Is it a SaaS that we're operating for stateful workloads or whatever, right? So again, you have to build. You start at the consumer, at the end consumer, right? The person who's going to be buying your product. You find those needs, and you're going to work backwards from there. Because in the end, like I feel like what the developers need is an API, pure and simple, right? As long as they have an API to deploy stuff or to do stuff with, they're usually going to be pretty cool. I mean, obviously, that's not going to fit everybody. There are going to be some other requirements you probably have to do, around the way somewhere. But for a lot of businesses that are doing platform engineering, the developers need an API. Operations is going to need some kind of observability harness and some way to have an automated way of reacting and interacting with their hardware, right? When you take these kind of base requirements, you mix in your business goals and strategy, what kind of timelines you're working with, what kind of engineering expertise you consistently have, or what you have to build, right? And you figure out on the whiteboard what you're going to build, right? And you're going to do it just like you would do any other product, because that's what you're building, right? But not to steer too far away from your original question, I think the main thing that the businesses are going to want to look out for, I guess, is like I said, what are your motivations for doing this, and that's going to dictate a lot of what you do next.
It's really interesting to hear your perspectives on this. And Robert, would you like to expand on what Tim just mentioned,
No, I
or
think he
even
summed it up.
Marina?
He summed it up quite nicely there. No, nothing to add.
Marina, would you like to add on to what Tim just mentioned?
No, Tim just shut me up. So it's hard to top that, to be honest. So maybe Akansha, we can, if you've
Okay, we
got
can
more.
move ahead.
Yeah,
Yeah.
let's go ahead.
So, maybe we could explore a bit about the inner workings of an IDP. From like what I understand about it, it's a ton of automation that goes on behind a GUI-based dashboard, and this automation is mainly for handling infrastructure components like your VMs, the Kubernetes cluster running on top of those VMs, databases, and other stuff. So, from a technical standpoint, how exactly is this thing working behind the scenes?
So IDPs are going to be built very differently, but the purpose of it is to essentially offer up an API to developers so that they can simply provision and deploy what they need for those particular applications. But it's not just free resources that show up out of nowhere, right? Someone's going to build this all out and make it available to them. So when you think about it, at the core, it's really storage, compute, networking, and the ability to add some layer of security. And when you think about that, you're basically carving out necessary resources as you need to for whatever style of workload that shows up. But it doesn't stop there, right? This is part of that entire CI/CD process. You build an application and it needs to land somewhere. That's the automation where you're not really touching, your Kubernetes cluster or your vSphere cluster or your Rancher cluster or doing anything there particularly. It's your pipeline that is responsible for that. But you're feeding instructions through your development processes, whatever you're writing as code, and anything new that might need to be packaged as a new container perhaps gets packaged and then provisioned and deployed as necessary. But there's also the life cycling element of it. As you're updating your containers and your apps, they get life cycled and then they are updated with newer features, or maybe your base operating system for those containers are updated as well because there might be a vulnerability that needs to be patched. But all this has to be automated, right? Before that automation, we were doing this by hand. We were going in manually and updating base images with updates. Here's a very classic example. Back in my operations days, like years ago, you would have to image servers so that they could provide some sort of function to either developers or whoever, like literally bare metal servers with an operating system. So you would use some imaging software. I don't know, maybe I used Norton something back then. I don't know what the hell it's called now. But it would just create an image with a golden image copy of an operating system, let's say Windows 2003 or something of that nature. And when that gets deployed onto that physical server, you power it on, and sometimes you would run a script to make that particular server unique on the network. So it's not like any other server, although the only other thing that would be different is its name. And what makes it unique is some special security identifier. This is like an old NT thing, but once it's unique, right, now it operates like every single other server, but we're still able to identify it. Now, the one interesting thing that happens is, let's say Microsoft pushes down a whole bunch of updates. Now I have to go in and do one of two things. I have to do both things actually. I have to update my golden image with those updates, right? And then so any new server that I decide to provision will get those updates. But in addition to that, the existing servers that I've already pre-provisioned and imaged, I need to go update them manually, right? By hand. I got to go log in and update those servers. this same process happens even at the container level, except we don't want to be sitting there and updating every single one of those base operating systems for a Kubernetes node. No, we want automation to take care of that. And the reason is because it's just an unnecessary waste of time. Like, it's a pure waste of time. So there's tooling, there's automation, and then there also has to be process wrapped around it too, right? You're automating a particular process so that you're not having to sit there and always seek approval from a particular board that has to approve change requests. I mean, this now can come in as a PR, and if a bot doesn't detect any sort of conflicts, then it should be mergeable into like some staging environment, and then eventually push to prod, and that could be handled too in a very interesting way. But behind all of this, right, there are processes, there's automation, there are people that have to sit there and build some of this initially. So there's an initial capex from an engineering standpoint, and that is the platform engineering. But then there's the ongoing opex, sorry, of you having to update your platform that you're offering up to developers or to your customer or to other organizations in your own company, that maybe some parts of your organization are looking at it from a FinOps standpoint. How much is this actually costing us to run? Is this good for our business, or is this bad for our business, or is this a lost leader for us so that we can attract customers to do and buy other things with us, right? That is truly what building a platform is. So it's multi-servicing. But now you think about tooling, right? And if I were to look at tooling, maybe I am a little biased because I spend more time in the cloud native space than anywhere else. I'd look at the cloud native landscape. It's not complete, but it's giving you all these different tools and pieces that you can use to effectively start building out a platform, an IDP that you can offer up to your developers. But behind all of that, someone has to sit there. Multiple people have to sit there and decide what is the best fit. And then decide later on that what they thought was the best fit was not the right fit. And now they've got to modify that. And that keeps happening over and over and over again because things keep changing.
Thanks for sharing, Marino. And I would love Tim or Robert to hear your thoughts on this. Yeah, please go ahead, Robert.
I think when we think of the platform and engineering concept is we tend to lean way too heavily on the tools and less on the product that the problem we're trying to solve and the people who are going to solve it, and how do we build a team that's going to be successful, and how do we empower them to pivot for that. And even when we talk about the cloud native space, we tend to sometimes forget that layer below it when we look at the Linux space, or the operational space below it. And I think we have to take a holistic look going from the top to the bottom to that.
Thanks, Robert. Tim, anything to add on to what Marino or Robert shared?
I think, Robert touched on something about, going deeper down in the stack and really examining what they're doing, especially when it comes to the platform. That, I think, is going to be where the real future of both platform engineering and our kind of cloud native culture as a whole, I think that's going to be where that lies. Platform engineering right now, almost always just takes existing tools and platforms, existing tools and applications or pipelines that we have, and then layers some abstraction over them to obfuscate some of the complexity, but it doesn't decomplicate anything. It just wraps the complication up in a like really nice little package there, and that's only going to keep paying dividends for so long. So I think if there's a real future for platform engineering, it's going to be actually decomplicating something, right? Actually removing, going down to lower and lower base layers, lower and lower levels, and giving engineers access to those things. But that's just me being like a grumpy old person who still wishes I could SSH into servers and run things. So take that for what it's worth.
Same. So let's think about any one of the big cloud providers. They offer up a platform, and that platform has continually grown. Like it just like every year you look at it, and it's like shit. There are more services, and you sit there and you think you're the consumer. You're actually consuming that platform so that you can go ahead and build your own platform. But who's actually building that platform, right? Who's building that platform, offering it up to you? So when you think about the cloud providers, they've basically sat there and engineered the shit out of, making sure that what they give you as a consumer is meant to be reliable and always available, and there's capacity for what you're trying to do, and you have all the necessary plugins to be able to see and do things and audit. But that particular form of platform engineering, right? We're talking massive scale, which is not going to be the same scale at which many organizations today, smaller ones, operate at, right? These organizations, like let's say Google or Amazon, that run these platforms and use them internally, they're doing exactly that. They're using them internally. They're cannibalizing these particular services through that platform while simultaneously giving you access to that platform as well. Now, do you want to sit there and take in all those practices and bring that into your organization? That could be a little overkill for depending on the size of your organization, right? And so you may have to like sit there and pick and choose and decide what the right pieces initially might be, and as your org grows, then you start to encapsulate and take in some more of those capabilities and pillars into the platform engineering strategy. Go ahead, Robert.
I think we need to caution everybody to watch out for the marketing hype when it comes to that. And I'm speaking for you're speaking. I'm in marketing, so I can tell you right now that's one of the things when something new hits a hyperscaler or anything that hits the market is to watch out for the marketing hype and don't be that early adopter thinking that it's going to solve a problem because marketing told you it was going to solve that problem.
And that's just it, right? Marketing doesn't solve that problem. Engineering does. And engineering not only is the one that decides, they're also doing the research, right? When you go to conferences, for example, these engineers are literally sitting in our talks, sitting in everyone's talks to listen and learn about new ways they can take some technology and process and ideas and implement that in their strategy. And when you think about that, that's a huge part. That's a huge part of building out a platform, a consumable platform, or even an IDP. So I think it was Backstage that last year just started becoming a massive hype because they offered up a platform, a developer platform that developers can consume and operations teams had access to be able to customize and even tie into systems like Kubernetes or other environments for that matter. But it's the stitching, right? It's the stitching that's required as well. Now, you fast forward to today, I think everyone's jumped on exactly what Robert said, that hype train, and is shifting some of the marketing messaging to basically say, hey, we offer up an IDP, or hey, we do platform engineering, or something that trigger or has triggering keywords that allude to the fact that it is platform engineering as a system or a solution or service that they offer up. So I agree, Robert. Watch out.
I want to say that I think marketing wise, we do a lot of art of the possible when we're talking about marketing, but engineering should really be concerned with the art of the practical. And I think that's where we really need to focus. Like, because when it comes down to platform engineering, no one's rebuilding AWS, right? We're rebuilding Heroku. And with that in mind, it's like we don't need to be able to do everything for everything and everyone, right? We need to be able to do like 5 things, right? Show me the 5 things that can do really well. Let me know the things that it can't do and what I have to tool around else. Like your platform is not everything. It's a start. It's a building block. It's a basis, right?
Yeah, that's exactly it, right? I seriously can't remember where I mentioned this, but I basically said what we're effectively trying to do is just go back to the model of what Heroku offered us. basically a simple way to just package and push our apps into production without having to think about anything in between. And that's brilliant, right? I mean, it was a brilliant system. Why did we move away from that?
Because they got bought by Salesforce.
But when Salesforce, okay, as an organization, you see its success. Why would you stop its success? That's what throws me off.
That's
Anyways,
what I mean. If we want to really get into the M&A conversation, name one company that got acquired, and the company that acquired it didn't ruin it. I will call into mind what AOL did to Winamp and ICQ as evidence.
Robert, go ahead.
So I want to ask the question of the group and get your guys' thoughts on how do you measure success within platform engineering? Is it just customer satisfaction? Is it time to market? Is it all of those things? What is it? What does success look like, and how do you put KPIs to that to show someone that they've done a fantastic job?
So that's going to go back to like, what was the reason that you did platform engineering in the first place, right? Your success criteria are going to be totally dependent on the problems you were trying to solve in the first place.
So can you have success even though, let's say, the product didn't do well, or the project didn't? I mean, is that still, do we roll it back and say that was because the platform team platform engineering let us down? I mean, can we have success from one and not the other?
I mean,
are they mutually exclusive?
I think you absolutely can have success from one, not the other. Like, it's like something failing is usually going to be a combination of reasons, not just the platform team, right? And so I think it's like when we define success or failure, right? What are our criteria? What does a failure look like? If you said the thing failed, like why? How, in what way did it fail? Did it not sell? Did people not like it? Because I can build a perfect platform, right? A quote unquote perfect platform, for a product that nobody wants. Is that the platform's fault? No, that's the leadership fault, right? I can build a perfect platform, but if leadership is not giving our devs the time that they need to actually develop, workable software, right, and actually something that's going to work well, then that's not a platform problem, right? So it goes along, like I said before, about organization defining what it is we're trying to do and why we want a platform in the first place, so we can have good success and failure criteria.
Marino, comment?
I have no comment. Oh my gosh! Every time Tim speaks, I feel like I'm slightly, I don't know what to say.
It's the smile. It's definitely the smile.
Yeah, it kills me too. How would my question now is, someone wants to learn or take a deeper dive into the platform, where's somewhere someone can go, right? What's the call to action that, what, I heard this talk, Tim's inspired me. Tim, where could I go? Marino, Asha, where could we all go? Where can someone learn more about this, right? And take that next step?
I'm going to say, like, first look at people who've done this, right? Like if I get cool with the notion of planes, I got to figure out, who's built planes before, like, let me see some planes, right? There are teams and orgs that have built successful and thriving platforms, even recently, right? So look at some of those, check out some of the architectures, check out some talks. I'm going to drop one that's a customer of ours that I hold up as like the be all end all of platform engineering and a mature, thriving enterprise DevOps culture, and that's going to be ING Bank out of Amsterdam. They did a talk at this last KubeCon about the namespace as a service that they built for their developers and internal and external applications. Right? They built this platform from the ground up. They did not use any cloud providers. They built it all on-prem. That's not a pitch. I'm just saying it can be done. But they took these needs, and these very complicated needs, like for a European financial institution, their compliance requirements are just unbelievable, right? And they built this platform that a vast majority of their new workloads run on. But that's where I would start.
I would also add, like, platform engineering itself as a practice, reading real world use cases of where, Tim shared one just now, but reading other real world use cases in the form of blog posts, and not, some company's blog posts. I'm talking about going on Medium or maybe Hashnode and seeing where folks have implemented practices around it would be a great way to start understanding what the mindset is, the road to get there, the decision making, and not just the tooling, right? But the stakeholders that are involved in this decision making process, because there is a lot of money that gets poured into something like this. It's not just, we're not talking about buying products, we're talking about people pouring in their time to sit there and decide how to best build a platform that is multi-service to everyone, or to their particular end users. And and so, because it's such a large investment, it's worthwhile really understanding what that investment looks like, right? It could translate into dollars and cents in some way, shape, or form, but that also translates into the failures, right? So that technical debt that's built up when someone decides, let's try this, and they run with it for a bit, and then they realize, oh shit, this is okay, but there's something else like right next door that is probably tastier. Try that out, and that works out better for them, and they just kind of like ignore the rest, right? So all of that initial investment is just gone, even though it might have operated the business for a little bit. So there are a lot of use cases that I recommend go checking out and seeing how this is how this is truly being done. What if you go on YouTube and you say, platform engineering, you're just going to find a bunch of people talking about what is platform engineering. And the best people to tell you what platform engineering are the folks that are actually doing it, the ones that are sitting there building a service, maintaining the service in a variety of ways, owning it, right? So owning all the decision making behind it and justifying the costs behind it, why the service needs to run. And then not only that, project managing the life cycle of that service as it continues to be built. So, yeah, I mean, when you go to talks, right, or when you go to conferences or meetups, you're going to find SREs doing platform engineering. You're going to find even engineers, like software engineers, that might end up in that platform engineering organization. Look for those talks, because they're going to talk about a specific problem and how they got there and then how they solved it, and not really throw a bunch of, hey, platform engineering, this, that, left, right, and center in your face. They're literally going to talk about the process and mindset behind everything that they do. There are also some excellent people that you could probably follow on Twitter. I'm going to have to go cherry pick and find out who they are. I know they exist, and they share some interesting use cases and some of the challenges that they faced. I'll tag them at some point. All right. Anyone else want to add anything else? I can hear Tim tapping away at his game.
Oh no, that was I was shit posting on Twitter because that's what we do.
Love it.
Okay,
Akansha?
so so like it's evident that like all these thoughts are actually enriching the conversation, and I really want to shift the gear in this space. So I had one question. Like build versus buy is a classic decision-making dilemma in technology and platform engineering. So how do vendor lock-in concerns factor into this build versus buy decision? How does platform engineering address concerns about becoming too dependent on specific cloud providers or technologies? And like, how does it handle a plug play model? Like, anybody
I'll
who wants
go.
to add thoughts
So
on
I
that
think
question?
build versus buy is always going to be a business decision, no matter what. Like it's not going to be a technological decision, right? In almost every single use case, right? Nobody's workload is such a snowflake that it can't be, fit into some existing set of tools, right? So it's going to be a matter of, does it make business sense for you to build it versus buy it? And a lot of the time, it's not going to make much sense to build it, right? But like you said, the vendor lock-in is going to be your biggest concern. How much do you buy? How dependent are you from someone when you buy it? Like like what is the I guess what is to what extent are you building versus buying? You know.
Yeah, I'll add with respect to build versus buy, it really comes down to time. If what you're building, right, requires you to build something extremely custom, and it's only ever going to be specific to your needs, it might be highly flexible to other users external to your organization. Then it might be a build it, right, build it scenario, and that might mean that the organization understands the time investment involved because it might take a longer time to get to that state, but it might be a specific use case, and that's something that might drive you to say, I'm just going to build it. In the buy it scenario, right, you're looking at it from the sense of, okay, I'm spending less time in the upkeep or maintenance of this platform that now I'm just going to be consuming, but then I lose out on customizability. Maybe there are some ways to customize it, but I don't have complete control on that customizability. Um, and it could also be very expensive. And depending on your organization, the larger you are, it might be easier, especially if you as an organization have plenty of cash on hand, might be able to make that kind of investment and say, let's just buy it and then learn how to use it and build on top of it.
I think
Smaller organizations.
I want to add to
Go
that
ahead.
end too. It's not just you build it and done if you build it yourself. You have to build it, maintain it,
Exactly.
upkeep, like all, upgrade, all that kind of stuff like that.
Patch it.
That
Yeah.
is a new product.
Exactly. And it's your own product because if you don't document it well enough and the team that builds it leaves or disappears, then now that is technical debt as
Mm-hmm.
well because now you don't have all the right information to literally maintain or manage it. So there are situations where the buy it approach is far more favorable. Yeah, it might be super expensive, but it might be much more expensive down the line to build it yourself in a lot of different ways. The other consideration, though, with build versus buy is if you're a very small organization, chances are you might even be building it because of the lack of available funds in your organization. So someone might say to you, "Look, let's just try and make this ourselves," and that could be another potential situation where that becomes technical debt.
If it's not adding to a differentiator in your product, you should just buy it. Right? I've met people who built their own Linux distribution off of a fork, and they're having a hell of a time trying to maintain it because they thought that's what you do, and it's not what you do because there's no real value in that. Now you have to support it, like Tim said.
Look, some people have built their own service meshes right down to the proxy level. Some people have taken Envoy and written on top of that. Some have taken Istio and done the same thing. And then you've got companies like us, like Solo, that built something on top of Istio so that you don't have to sit there and build it yourself, right? So depending on where you are, right? If you were early on as well, let's say you're an organization that grew up with a particular open source technology like Kubernetes or Istio, for example, you might have gone through the pains, but continue to stick with those pains and grown with those pains all the way throughout that journey, and then customized that particular instance of that installation to your needs. And now you just maintain it ongoing, right? So there's a guy out there, Carl Stoney, who deployed Istio at scale for AutoTrader. That's a use case of platform engineering right there, and in the way that they used Istio as a foundational piece of that platform, but they had to build other things on top of it to make it a platform for their developers to build on top of and deploy their apps to, while their operations teams or their platform teams can sit there and provide reliability capabilities to it. So go check them out. Sorry, go ahead, Tim.
No, I was just recovering from a sneeze.
Oh, bless you, man. All right, Robert, thoughts?
No, but thank you for inviting me. I do appreciate it.
Sounds like you might have to board soon.
That is correct, sir.
Got it. All right, Akanshi, I guess we should wrap up.
Can we just take a second to recognize Robert's
Sure.
smooth, velvety baritone?
Yes.
Well, thank you.
Yeah, like I had one last question, but yeah, we are running short on time, so we can end this space
What's
now.
your last question?
It was related to security, so if you don't mind, I can ask that question.
Yeah, go for it.
Yeah, so like we know that security is a critical concern, not just in platform engineering, but in a life cycle in general. So, how does platform engineering address the need for secure by design software systems, and how does it differ from the security practices in DevOps or rather DevSecOps?
That's too loaded of a question. I think we should just end the space now. I'm just kidding. No, no, no. Okay. Um,
I I
so
have an answer.
go ahead.
So
Go for it. Go for it. I know I hadn't wanted to, but go for it.
software is first and foremost an architectural concern. So you solve it on the whiteboard most of the time, right? So when you're talking about in reference to platform engineering, it's baked in, right? It's not an afterthought.
That's exactly it, right? You want to start implementing your security practices right at the software stage as you're designing it. You know, what are the right pieces? How do you implement the right components so that you don't have like a buffer overflow or something of that nature in your code, or a memory leak or something of that nature? And you sit there and if you have that in place, that's not the complete picture, because you'll have dependencies that you also have to validate, right? You have dependencies that you have to use for your app to function properly. And so those dependencies might be third party. They're third party. Now you're reliant on them to update it. You could potentially, if they've open sourced it, you could fork it and then maintain it yourself. But now that's additional that's additional overhead that you have to now manage and maintain. So along the way, right, all of this should be automated and checked and constantly checked, you know, in a repeated fashion every so often, to see if there's any sort of drift in configuration or versions or vulnerabilities or state. And because of that, you know, the reconciliation aspect of it is pretty critical. So when you tie that all together, your platform that you're building has to be secure from the moment you start writing your software and architecting it, all the way to through it running somewhere in production. And there are going to be multiple pieces and tools, and even um, organizational policies that come into play here. Like, for example, if you're a government organization and you have a strong FIPS requirement, what does that mean? Like, that truly means that the technologies that you use have to be FIPS compliant. That's a specific example, right? And this gets called out, and now that gets factored into the decision making of how this platform gets chosen or built. So there are going to be guidelines that have to be fed from the business, and then on top of that, if that business is somehow expected to be conformant or compliant to a lot of security standards or government security standards, then guess what? Those standards fall down to the platform team to implement somehow.
Tim, would you like to, are you saying something?
Nope, nope. Just playing Call of Duty.
Oh, uh, okay, so yeah, like it's clear like you both have like super valuable insights, and thank you so much, Robert, Tim, and of course my co-host Marino for adding so much value to this space today. I really enjoyed this conversation. And Marino, any last thoughts before ending the space? And Tim, Robert, yes, please go ahead.
Yeah, so I think we're going to have a part two of this, because I spoke with a few folks, someone who's writing a book on platform engineering, who actually works directly with customers, and I want them to come in and share specific use cases of how their clients or customers are building out platforms and platform teams and organizational processes around platform engineering. So we'll keep you informed, let you all know when that happens. You know, we'll throw out a graphic and even schedule that space. Not sure when, probably in a few weeks from now, but I just got to find out the availability of that speaker. Tim, Robert, any final thoughts?
No, nothing. Just yeah, just like check it out. Like first and foremost, check it out. Jump in the community. Ask all the questions, please, and yeah, keep the conversation going on Twitter or wherever else. Like this is how community works. We talk about things, we get things right, we get things wrong, and we keep going.
Hard to follow up Tim on that, but I want to thank everybody for coming and thank you for hosting.
Yes, absolutely. Thank you so much, Marino. and Akansha. Did I pronounce your name correctly?
Yes, yes.
Yeah.
Awesome. Well, thank you again, everyone. Thank you, Tim, Robert, Akansha, for all your gracious answers and sharing your knowledge with the rest of the community. We'll do this again soon, everyone. Take care. Have a great rest of your day or evening or afternoon or wherever the heck you are. Enjoy. We'll chat soon.